Hi, today we will see this aircraft computer box. So this is the computer MacTrim compensator. It was installed in a DC-8 aircraft. I have the paperwork for that. I have the FAA form 8130. And I have also this document. Okay, so this one was verified in 98. The pitch trim compensator permits to compensate the nose-down attitude of the aircraft at high Mach number because of the displacement of the center of pressure to the aft of the aircraft. For that purpose, there is the modification of the position of the elevator of the aircraft. We can see on that graph the correction of the elevator here according to the Mach number. So this is why there is a pitot-static input pressure on that device in order to compute the Mach number. So first we will see what is inside, and after, if it is not too complicated, it can be interesting to do the reverse engineering, and after that it can be interesting to get it work. So first let's open this thing to see what is inside. Okay, look at that. This is the old school construction, point-to-point wiring, but this is beautiful. In the center of that device, there are the pitot-static sensors. Yes, and it seems that there are several potted modules. Look at that. We can see the dead code on this electrochemical capacitor here, 66. But it is strange because there is a dead code of 95 on the power supply here. Look at these big transistors. Strange package. This one, there are two other transistors here on the same package. This is the full transistor design. There is no IC on that thing. Okay, look at that. We can see here probably a dual transistor, dual JFET or dual bipolar transistor. There is another one here. We can see that there is a large number of trimmers. They are socketed. They are manufactured by Spectral. That code 68, it seems. This is a small transformer. You can see that there is a steel screen on this metallic plate for all connections. Look at that here, for example. You can see this black line here. So there is a black line for each connection. Okay, we can see more details on the sensors. We can see that there are 3 wires for each sensor. So the output is a potentiometer. We don't need a very high accuracy for that device. Okay, we can check the resistance. For example, this one. So here there is a resistance of 57 kilo ohms. And here 55. 3.5 kilo ohms, so this is effectively a potentiometer. The maximum is here, so the whipper is this connection here. It is possible to disconnect the pressure sensors. Okay, it is very difficult to remove. Okay. Okay. This is the pressure transducer. It seems absolutely impossible to remove the cover of this transducer. I tried by using a vise. You can see, and I tried to remove the cover. It can move a little bit. It is very difficult to open. We can see the other side of this board. We can see this big transistor, or SER, I don't know. It is written 154, let's see, 164-08. I cannot see the manufacturer. Let's see the logo. And look at this very nice transistor. Military specifications, JAN 2N1485. That code 89. Made in USA. And this one, DTG2100. And this seems to be a temperature sensor here. Maybe a transistor, but I have never seen such package. There are 3 pins anyway. That's all for this first episode. Thank you for watching and see you next time. Bye bye.